So in this video we want to come up with equations for horizontally and vertically translated cosine and sine functions by looking at their graphs. And one of the things we want to identify before we start is that there's going to be infinitely many correct answers or equations that describe a given graph. So all we can do is say find a function that models. We can't say find the function. We can't use the definite article when we're doing these. So let's say, for example, we want to model this using the sine function. We've got a couple of options. So one, we could look at this and we could say, hey, it looks like I could use a reflected sine function, and I'll trace out one period. A reflected sine function, and starts here, we wind up back where we began right here. I could use a reflected sine function, and that would give me a model. I could also notice that I could use a sine function that's not reflected over the x-axis if I want to start right here. So I could use a sine function that's been horizontally translated but not reflected. We could use a reflected cosine function by starting here and beginning our trace. We trace through one period of a reflected cosine function, and I could also use a cosine function if I want to start up here at a peak where the cosine function usually starts and run down through one period. So there's lots of ways to come up with a model. So let's suppose we're going to use this. We'll do a model just using the sine function in this case. So the first one we'll do is this guy right here. We're going to say we're going to use a reflected sine function. He's reflected over his midline or x-axis, or he was originally reflected over his x-axis, but currently he's reflected over the midline. Reflected over midline, which was the x-axis before it was vertically translated. And what we want to do is trace through one period. So there's one full period. We've gone through one cycle. And what is the period? Well, the period is the distance over which we sweep through one cycle of the sine function. So the period is 2 because we have to go from 0 to 2 to get through one cycle. So the period is 2. The midline, which we can actually see the midline, but it's also something that we can calculate. So the midline, what we want to recognize is the midline is halfway between 7 and 3. Here's the crest at 7, a trough at 3, so the high point on the graph is 7, the low point's a 3. So the midline, or the vertical shift, the midline and the vertical shift are going to be the same thing. The midline is actually the average of the low point and the high point. Halfway between is the average. So we could go 7 plus 3 over 2 is 10 over 2 is 5. So the midline here is at y equals 5. And the amplitude is half the distance between the crest and the trough, or the distance from the midline to the trough. So one way to get the amplitude is to take one way to do it. It's not the only way, but one way is to say what's the distance between the top, the crest, and the trough. So 7 minus 3 is 4, is the distance between crest and trough, and then halve that distance. And we see when we could have just looked at the graph and counted it, but this distance is 2. We can calculate that as a 2. And we have no horizontal shift, so we can kind of start to set up a sine function. We could say, hey, one model for this is f of x equals reflect the sine function, so it starts going down, to negative 2 times the amplitude times the sine of, it's going to be bx, usually it's bx plus c plus d. There isn't going to be a plus c because we're not, if we start here, we're not horizontally translated, we're just vertically reflected. So there would be no c, so it would just be negative 2 sine bx plus d, but d is the vertical shift, which is 5 units, or the same as the midline, so plus 5. And then we just need to figure out what b is. But remember the period, if this is the function outputs and this is the x-axis, this is really this period of 2. This is x equals 2. That says plug 2 in for x and see when you get to pi. So to figure that out, we say bx equals 2 pi, but the period number is 2. Right here, this 2 is x equals 2, so we replace x with 2 and solve for b. Divide both sides by 2, we get b equals pi, and I can come in here and replace the b with a pi, and I have an equation that would model that function. But I could also decide to model it using a sine function starting right here. So I could sweep through. Here's one period. Notice the period. Here's where I start. Here's where I end. The distance between those two numbers is still 2. The period isn't going to change just because I am looking at the graph from a different perspective. The period is what it is. The midline is what it is. The amplitude is what it is. The only thing that's going to change here is I'm going to need to shift a sine function out 1 unit to the right, and I won't need to reflect if I start my graph from right here. So let's make another function, g of x. Instead of a -2, it'll be a +2 because we're starting here and going up. It is going to be sine of bx plus d. There will be a horizontal shift that I need to do to get the sine function. Usually starts here. Now I need to get them to start over here. And it's still going to be plus 5. And I've actually already calculated b. b is pi. b won't change just because I'm choosing to use a horizontally shifted sine function. So b is still pi. So remember, when we were graphing, what we would do to figure out the shift is we would factor the coefficient on the x out to understand what was being added or subtracted from a single x. So we do pi parentheses x, factor out a pi. That's going to make this plus d over pi. Pi would distribute in and give us the d back, plus the 5 units. And when we factor, this is the thing that's being added or subtracted from x. This is the shift. We should replace this piece here with the shift. I have it in factored form. And the shift is 1 unit to the right. I'm starting here. I'm moving things over 1 unit to the right. So to shift a graph 1 unit to the right, I do -1. And then to put it into standard form, I can distribute that pi back into the parentheses. So 2 times sine pi x minus pi plus 5. So in this example, what we want to do is model this 2 ways. We want to model it with a cosine function and with a sine function. And one of the big ideas here is that anything that you can model with sine, you can also model with cosine, because the sine and cosine functions are just shifted versions of each other. So let's say we start with sine. So sine looks like it would be starting in its standard position on the midline, not reflected, and sweeping through 1 full period. So there's 1 full cycle of the sine function. Starts at 0, ends on 16, which tells me that the period is 16. So that's the first thing I get out of this. The midline, which I can see looks to be about 70, but I can also calculate it as the average, the midpoint, or the midpoint between the bottom, the trough, which is at 20, and the crest, which is at 120. So the average of the crest and the trough, the average, is going to be 140 over 20, sorry, over 2, because I'm taking the average. I don't know why I did that. Divided by 2, which is 70. So there's my midline, or my vertical shift. My amplitude is half the distance, right? The amplitude is the distance from the midline to the crest, or the midline to the trough. So it's half the distance between the crest and the trough. So the amplitude is going to be, take the distance between the crest and the trough and take half of it, which is going to be 100 over 2, which is 50. So the distance from here to here should be 50 units. So I have amplitude, I have period. Notice there's no horizontal shift if I'm using the sine function. So I can start to set up my sine model. My sine model is going to be A sine bx plus d. There's no plus c because I have no horizontal shift. And I can look at maybe feeding some numbers in that I know already. A is the amplitude, which is 50, times the sine. This is going to be a bx plus the vertical shift, which is the midline, or 70. And I just need to figure out what b is, but I know the period is 16, and I want to recognize that if this is my x-axis, this is saying that x is 16. So we're replacing this x with a 16. We're saying, hey, b times 16 needs to equal 2 pi, or once around the unit circle, we divide both sides by 16. We get b has to be pi over 8. So I can make my replacement right here, replacing b with pi over 8. So if we're going to model using the cosine function instead, what I would want to recognize is that it looks like the cosine function, which usually starts at its high point and moves down to its midline, is actually being shifted over, and this is a 4, it's being shifted 4 units to the right. So the cosine function would have a shift of 4 units to the right. So the cosine model is going to look like, we'll use something other than f of x, because we used f of x for sine. We'll use g of x for the cosine model. It's going to look like a times the cosine of bx plus c plus d, but the a, the b, the d are all going to be the same a, b, and d that they were for the sine function. So we can just make those replacements. A is 50. We get 50 cosine of b. b is pi over 8 x plus c plus 70. The midline is at 70. And then again, just like before, we want to recognize that when we were graphing, what we did to find the horizontal shift is we went in here and we factored the coefficient off of the input variable x, so that we could determine what's being added or subtracted to x. And if we do that, this is a c. This is going to wind up being c divided by pi over 8 plus 70. And this term here actually is going to be the horizontal shift. So if I clean out this mess, so I have it in a factored form, should have in parentheses there. I factored the pi over 8 off of everything. The shift goes here, and it's the shift of the cosine function 4 units to the right, so it needs to be a minus 4 to get it to go 4 units to the right. And then I can distribute this into the parentheses to get it into the standard form if I want it in that form. So I get 50 cosine pi over 8x minus pi over 8 times 4 is going to be pi over 2 plus 70 units upward vertical shift to the midline.